If the work W done by a force F displace an object by distance d, so here's our distance d that we've been displaced, and our force F, the angle between F and D is theta, then the work is the length of the force times the length of the displacement times cosine of theta. In other words, it's the force dot the displacement. Suppose a force F, which is equal to the vector 2, 6, 7, newtons, moves an object from the point P, 101 to Q, 202 meters. What is the work done by the force? Well, we first need to find our displacement vector. So Q minus P gives us 1, 0, the vector 1, 0, 1. So then we have the force vector dot the displacement vector. So we have 2, 6, 7 dot 1, 0, 1. So we have 2 plus 0 plus 7. So we have 9 joules of work were done. When we have an object, this red box, sitting on a plane, the black triangle, its force is its weight pushing downward, this blue vector here, and let's say this box weighs 20 pounds. So the force vector is 0, negative 20. We are interested in the parallel component of F, which is the component going down the incline, which indicates how likely the box is to slide down, and also the normal component of F, which is how likely the box is to stick to the plane. And if we know the angle of our plane, in this case is 30 degrees, then we can find our normal component and our parallel component. So first notice that this blue vector F, using our parallelogram addition rule, is the normal component plus the parallel component. So if we call our normal component n and our parallel component p, n plus p equals f. At the same time, we notice that the parallel component, we have this perpendicular here, so our parallel component is the projection of f onto a vector v, where this vector v is the vector going down the plane. So trying to determine the position of the head of this vector, if we look at our plane, so here's our plane, and here's our object. We're looking for the position here. So if this is 30 degrees, that means that this angle right here is also 30 degrees. So if we look at what is just for 1 unit's distance, what would the position be? Well, at 30 degrees, or negative pi over 3 degrees, we are at the vector square root of 3 over 2, negative 1/2. So that is our vector v. So to find our projection of f onto v, we need f dot v over v dot v times the vector v. So we have 0, negative 20 dot square root of 3 over 2, negative 1/2 over square root of 3 over 2, 1/2 dot square root of 3 over 2 1/2 times the vector square root of 3 over 2 1/2. Alright, so this top dot product, we get 10, we get 0 times square root of 3 over 2 plus negative 20 times negative 1/2, so 10. On the bottom, we get 3 over 4 plus 1 over 4, so we get 10 over 1, which is just 10, times the vector square root of 3 over 2 1/2. So our parallel force is going to be 5 square root of 3, 5. And now to find our normal force, well, the normal plus the parallel equals the force. So normal force equals the force minus the parallel component. So our force was 0, negative 20. Our parallel component was 5 square root of 3, comma 5. So our normal component is negative 5 square root of 3 minus 25.